In Lahore's urban landscape, many sources contribute to air pollution, prominently including vehicle emissions, industrial outputs, and open biomass burning. These sources release a cocktail of nitrogen oxides, particulate matter, sulfur dioxide, and volatile organic compounds, significantly deteriorating air quality and public health. Vehicles, a major contributor, are responsible for over 40% of air pollution, exacerbated by traffic congestion and outdated technology. Industries add to this with emissions of sulfur dioxide and nitrogen oxides, while agricultural practices and biomass burning, particularly crop residue incineration, spike particulate matter PM 2.5 levels during harvest seasons. Air pollution is an obvious outcome of construction activities, and PM is one of the sources of air pollution. Particulate matter is a group of polluting agents consisting of dust, smoke, and all types of solid and liquid materials that remain suspended in the air because of their small size. PM 2.5 refers to particulate matter that is 2.5 micrometers in diameter or smaller. To put this into perspective, a human hair's diameter ranges from about 50 to 70 micrometers, making PM 2.5 particles at least 20 to 30 times smaller than a human hair. Due to their tiny size, PM 2.5 particles can bypass the nose and throat's natural defenses, penetrating deep into the lungs. From here, they can even enter the bloodstream, posing severe risks to respiratory and cardiovascular health. Moreover, they can carry surface absorbed toxic substances, including organic compounds, heavy metals, and carcinogens, directly into the lungs. This makes them not just a threat by virtue of their size, but also because of the dangerous chemicals they can introduce into the body. Numerous scientific studies have linked exposure to airborne PM to a variety of health problems, including premature death in heart and lung patients, heart attacks, irregular heartbeat, aggravated asthma, lung disorders, as well as irritation of the airways, coughing, and difficulty in breathing. In 2019, around 3.7 million premature deaths were attributed to ambient air pollution worldwide. Moreover, it had been reported that nearly 88% of deaths in low and middle income countries were associated with airborne pollutants. PM is also suspected of being a factor in climate change. PM particles exhibit a range of light absorbing and scattering properties, altering the climatic cycle in this way. The warming and cooling effects of PM are determined by the nature of the particle or mineral present in the atmosphere. Moreover, I want us to dive a bit deeper into how the pollutants in the air interact with our genome, which is constantly changing according to the environment around us, and these epigenetic changes can be inherited. I had interviewed an RA at LUMS who had worked on the impact of air pollution on the genes of houseflies.
To study was that what are the molecular effects of the particular of a particulate matter that we are experiencing in extremely high amounts in Lahore, and secondly, what is there, and if there is a transgenerational impact of those
Particulate matters, PM 2.5.
Those molecules. So I initially actually wanted to focus solely on PM 2.5 pollution, but isolating 2.5 micron particles was a bit of a challenge for us. So we then decided to go for fully particulate matter.
Okay.
So I did not filter particularly for 2.5 micron because for that you need a complex sort of equipment that we do not have, unfortunately. However, so the advantage that I had in this lab was that we have a very robust model organism in the form of Drosophila melanogaster. And Drosophila is basically the fruit fly, for those who don't know. It's basically the fruit fly, and it is a model organism that is used very commonly in genetics. And the reason that it's used very commonly in genetics is because there is a lot of homology between, and homology means there is a lot of similarity in genes between humans and flies. And so a lot of these studies can then be used to extrapolate our data or what we discover onto mammalian cells and human cells in general. So that's why I decided to use this particular model organism. Yeah. So so the particular gene that I found, which is responsible for maintaining the cell cycle in humans, I found it to be downregulated in these flies after I treated them. By downregulation, I mean that there was supposed to be a particular amount of this protein, but now a much less amount of this protein is being produced. And we know for a fact that such disruptions in the gene regulation code definitely do result in adverse health effects. It could lead to cancer, it could lead to tumor formation. And so this was one of the results that we found to be replicated over generations actually. So over multiple because we were doing this treatment over multiple generations of flies, so we found this result to be duplicated over generations. And this was a very significant finding for us because it is giving us an indication into how these air pollutants are actually responsible for disrupting the cell cycle. It could lead to cancer phenotypes. Another sort of thing that we definitely know about air pollution is that it does trigger the oxidative stress response. So I'll just tell you a little bit about what that is. Is that these pollutants, the PM 2.5 pollutants, the oxides, they generally tend to create free radicals in the cells, oxygen free radicals, and these free radicals generally cause damage to the DNA, or what we know as mutation, right? And these sort of radicals tend to directly cause damage to the DNA. And as a biologist, it is a very known thing that mutations generally lead to cancer. So this again is a very, very concerning sort of thing that we've looked at. And so the purpose of this study was to look at this particular stimulus in more detail, and to be able to actually understand the gravity of the situation that we face, and hopefully raise more awareness to actually bring about actionable policy to fix it and to help out the environment.
While precise statistics on the contribution of construction activities to Lahore's overall air pollution might not be readily available, studies in similar urban settings suggest that construction sites can be notable sources of PM10 and PM 2.5, especially in rapidly developing areas like Lahore. It's not all that bad, though there's still some hope. Some suggestions that could help alleviate air pollution in Lahore. Transitioning to electric public transport and ensuring all vehicles have catalytic converters is essential. To reduce traffic jams, alternate routes should be offered. Regular vehicle safety checks, especially for heavy transport vehicles, are necessary. Restrictions on low-grade fuel usage are critical since buses using poor fuel significantly emit sulfur dioxide. Industrial estates should be relocated outside urban areas to minimize pollution concentration, while industries must adopt smog control technologies. Collaborating with green architects, environmentalists, and policymakers is vital for creating sustainable structures and regulations. While these are solutions to much broader problems, I started thinking within the context of slums and how change needs to start at home. The issue of PM 2.5 gets exacerbated when combined with the persistent construction in slums. Construction sites are significant sources of dust and PM. While slums has been taking precautionary measures such as safety nets to prevent excessive dust from coming outside, I wanted to interview the construction workers to evaluate the impact of being exposed to such hazards on a daily basis and thus extrapolate the impact onto those who live near these sites. However, the workers informed me that I had to get permission from the administration at slums to record their interviews, thus I will just explain their statements. However, our on-site observations painted a different picture. While filming workers engaged in tasks including sealing the windows of the library, it became evident that the adherence to these SOPs was inconsistent. Despite the manager's assurances, many workers were seen without protective gear, exposing them to potential health risks associated with construction. I also went and talked to several Ayabajis. Majority of them stated that they were unaffected by the air pollution and that their biggest concern was to get food on the table. It is important to give these voices a platform as well so that one may realize that such individuals are the most disadvantaged in our system, as they have to bear the brunt of the air pollution and not even have resources to be healthy or have access to good health care. A lot of the Ayabajis had stated that they had a family history of diabetes or health-related issues, which are both linked to air pollution, as PM 2.5 causes resistance to insulin and so forth. Now I will share an interview that I had with two Ayabajis who had agreed to be on screen. And आपका?
मेरा तो अभी भी सर में दर्द है। कल भी शाम को जाके बड़ी तबीयत खराब सर के दर्द से ही हुई थी। तो गला वगैरह मेरा नहीं वैसे इतना
खराब रहता है।
हाँ जी, सर में ज़्यादा।
ओके। और आप लोग को सांस वास के कोई मसले होते हैं या?
नहीं, सांस का तो नहीं।
एंड आप लोग के कोई फैमिली में कोई मसले हैं लाइक दिल के या हार्ट अटैक के या इस तरह के?
नहीं, मेरे फिलहाल तो नहीं किसी के।
ठीक है। और कोई बीमारियां या कुछ खानदान की?
नहीं, ऐसी कोई मतलब ज़्यादा नहीं।
अच्छा, ठीक है। हेल्दी फैमिली, दैट्स नाइस।
हमारे पास ये थोड़ी सी शुगर थी मकसद बड़ों में, जैसे दादा उनकी तो डेथ हो गई। अभी मेरे अब्बू को है।
तो कंस्ट्रक्शन जब हो रहा होता है तो उसका लाइक मिट्टी कभी मुंह पे आ रहा होता है या फिर उधर सांस लेने में मसला होता है या फिर आँख में लाइक आंसू आते हैं या फिर इरिटेशन होने लगती है या फिर आप लोग सही होते हैं लाइक लम्स के वो ये जो सारा कंस्ट्रक्शन हो रहा होता है सारा कुछ?
नहीं, थोड़ा बहुत तो होता है, जब बाहर जाते हैं तो मट्टी वगैरह का तो होता ही है थोड़ा बहुत। इतना नहीं है लेकिन है ज़रूर।
एंड क्या बोलेंगे कि यहाँ बेहतर है लम्स के अंदर जो लाइक यहाँ एमिशंस भी कम होते हैं क्योंकि ट्रक्स भी कम हैं एंड लाइक बाहर रोडों पे तो बहुत ज़्यादा ट्रैफिक होती है, रोडों पे पूरे इंडस्ट्री भी होती है सारा कुछ। तो फिर वहाँ क्या आप आपको वहाँ सांस लेने में ज़्यादा घुटन आती होगी या फिर यहाँ लाइक सही है लाइक क्या?
लम्स के अंदर काफ़ी बेहतर है।
अच्छा हाँ, वहाँ की मुझसे ये यहाँ की आदत हो गई है, दूसरी चीज़ें कभी फेस नहीं ना की, अगर उस माहौल में बंदा जाए तो ज़रा सी बात मुश्किल होती है।
तो फिर लाइक आप यही बोलेंगे ना कि लाहौर में मोस्टली काफ़ी ज़्यादा मुश्किल है, साथ लाइक डिफरेंट कंजेस्टेड एरियाज हैं। ठीक है। Staff near the open gutter at Lums expressed concerns about its odor and health risks, feeling neglected despite repeated pleas for action. They suggested constructing walls around the gutter to contain the smell and emissions. The impact of such odors on human health, particularly on olfactory nerve cells, underscores the seriousness of this issue, as highlighted in Hamoda's study. Wastewater odors stem from various sources, including human waste, which introduces ammonia and scatol, and industrial discharges that contribute high concentrations of toxic and reactive compounds. Anaerobic biological processes lacking oxygen and nitrate produce odorous substances like hydrogen sulfide, aldehydes, amines, volatile fatty acids, and VOCs in sewer systems and rising mains. It should be emphasized that odor emissions in sewers depend on the ventilation, slope, and other environmental parameters such as temperature, changes in surrounding pressure, type of flow, laminar or turbulent, and so forth. Thus, one can imagine the heat of Lahore exacerbating the odor emissions and thus exposing passerbys to increased toxic emissions from the Nala. Lums is responsible for ensuring that all workers are protected and SOPs are adhered to. This commitment extends to the well-being of its students and significantly improve indoor air quality by capturing fine particulate matter, thus offering a safer environment for everyone on campus. Furthermore, the adoption of dust control measures on construction sites and the use of low-emission equipment would contribute to a reduction in air quality degradation. Embracing green building materials and practices is crucial in promoting sustainability and minimizing pollution. These steps are not only essential for immediate health and safety concerns, but also reflect a long-term investment in environmental stewardship and the well-being of the Lums community. Speaking of green spaces, the role of trees in mitigating air pollution cannot be overstated. They act as natural air filters, absorbing pollutants and producing oxygen, which is essential for life. Their cooling effect, especially in urban areas, can reduce the need for air conditioning, thus lowering energy consumption and greenhouse gas emissions. However, deforestation for industrialization and urbanization, as observed in the case of Lums, poses significant challenges. Removing trees not only diminishes these benefits but also impacts biodiversity and ecosystem services. To combat air pollution effectively, we must advocate for a holistic approach encompassing technological innovation, regulatory measures, and community engagement. This includes integrating sustainable design and green infrastructure into urban planning, ensuring compliance with environmental standards, and fostering collaborations between academia, government, and communities to address air quality issues. It's about creating resilient, healthy environments where people and nature thrive.